Welcome to section 6.3, featuring my cat, Theodore. Say goodbye because we're going to start talking about logarithms. And he will not make an appearance. Well, he might. Who knows? So we're going to start, before formally introducing logarithms, let's remember some things about inverse functions. 3.7, I believe, was inverse functions. And we had some examples of inverses. All right. And here are some of them. If 2x equals y, how do we undo that multiplication? We undo that multiplication with division. We would say x is equal to y over 2. Or you could think about it as multiplying by the reciprocal. All right, we had addition, right? If we had addition, how do we undo that addition? Well, we would subtract. Subtract 3 from both sides, and we get y minus 3. If x was getting cubed, how did we undo that? Well, if x was getting cubed and we wanted to undo it, we would take the cubed root of both sides. So these are all equivalent. In fact, these arrows go in both directions. These two things mean exactly the same thing. Okay? This and this are exactly the same mathematically. And the same for all of these. And so that's what we're going to do in this section. What if I have an exponential function? Well, how do we undo the exponential function? Well, so far we can't. But with this one trick, mathematicians hate him, we can do this. And this is what we're going to write. That in the same logic as these other three, that x is equal to the log base 2 of y. All right, and this is basically what a logarithm is. Okay, so there's a little bit of vocab to talk about here. This first thing over here, this is called exponential form. And it means literally the same thing as this thing over here, which is known as logarithmic form. This 2 is a subscript. This is called the base. This whole thing is said log base 2 of y. That's how we pronounce it. That's how we vocalize it. And again, that base is a subscript. So notice a couple things, right? The base of the exponential function is the same as the base of the logarithm. That's one way to remember things. And all a logarithm is, let's write that down. All a logarithm is the the inverse of an exponential function. If you remember nothing else from this entire week, remember this. Well, and like remember to eat and stuff too, and drink water. But logarithms are just the inverses of exponentials. I'm going to say it 50 times, hopefully. Logarithms are just the inverses of exponentials. So again, in general, right? In general, right? Log base b of x equals y just means the base of the logarithm is the base of the exponential. The input of the logarithm becomes the output of the exponential. And the output of the logarithm becomes the input of the exponential. Inverses, right? Inverses were all about switching inputs and outputs. So the logarithm is just the inverse of the exponential, right? We're at like 3 at least out of the 50 that I'm going to try to say. So this is, again, these are equivalent. These mean the same exact thing. So if you're wondering what a logarithm is, this is what a logarithm is. It's just another way of writing an exponential equation. So let's see this in more concrete terms with example 1. All right. And graphically, you can see a lot of stuff here too, but that's next section. All right. Convert the following. Between logarithmic form and exponential form. So I'm just going to give you either this or this, and I want you to translate. Because sometimes we want logarithmic form. Some things logarithmic form is easier. Sometimes solving equations or using special properties of logarithms. And sometimes exponential form is easier. Computation is usually easier in exponential form and stuff like that. So it's very useful to be able to switch between both of them and then just choose whichever one's more useful for your task at hand. So part A is going to say log base 6 of the square root of 6 equals 1/2. So this is a true statement. This is an equation in logarithmic form, and this is truth. Mathematically true. The log base 6 of the square root of 6, that is equal to 1/2. We'll actually compute logarithms in the next video. But this is not asking you to compute anything. Just say, well, it's in logarithmic form. How do we convert that to exponential form? So I always like to start. The base of the logarithm becomes the base of the exponential. So 6 is the bottom of our exponential function. This b is the same as this b. B for base. The input of the logarithm becomes the output of the exponential function. The square root of 6 comes over here. The output of the logarithm becomes the input of the exponential function. So it goes up there. And this is indeed true, right? This is what rational exponents are all about. Fractional exponents. An exponent of 1/2 just means the square root. So these are both true statements. This is a true statement in log form. This is a true statement in exponential form. And that's all we're doing in this video, really. Let's just do a bunch more. Log base 3 of 9 equals 2. Again, this is a true statement. The base of the logarithm becomes the base of the exponential, 3. The input becomes the output, 9. And the output of the logarithm becomes the input of the exponential. 3 squared equals 9. Yeah, that's true. This is true. This is true. Just written differently. All right. All right, let's go the other way. Let's say 2 cubed equals 8. So now we're starting in exponential form, again with a true statement. It's not asking us to solve anything or simplify. Just write this equation in another form with logarithms. The base of the exponential function is the base of the logarithm. This is log base 2. Output becomes input. Input becomes output. Log base 2 of 8 is equal to 2. Wait, no, that's not true. That's 3. Log base 2 of 8 is not equal to 2. Log base 2 of 8 is equal to 3. They should both be true statements. All right. Very good. Let's do another one. Part D. 5 squared equals 25. Same thing. What's the base of the logarithm? It's the same as the base of the exponential function. The input of the exponential function becomes the output of the logarithm, and the output of the exponential function becomes the input. Inverse functions are all about switching inputs and outputs. X's become Y's, Y's become X's. Inverse functions, 3.7. Might be worth a review because that's all this section is. Logarithms are just the inverse functions for exponentials. Keep counting. You tell me how many times I say that in this section. So again, this is a true statement, just in logarithmic form. Part E, 10 to the negative fourth equals 1 over 10,000. Remember negative exponents. Fractional exponents mean radicals. Negative exponents means reciprocal. All right. What's the base of the logarithm? 10. Input becomes output, out becomes input, and so on. This is a true statement. Let's do 2 more. Log base 4 of q equals m. Well, I'm assuming this is a true statement, but I don't really know what m and q are. But either way, we can do the same thing. This becomes 4 raised to the exponent of m equals q. We can do this all day. 4 to the x, 4 to the x equals y. We just do the same thing. This is log base 4, right? I'm doing so many of these. They're all the same. Input becomes output. Out becomes input. Out becomes in becomes out. Switching x's and y's because logarithms are just the inverse functions of exponentials. All right. Anyway, let's do one final example for this video. Example 2. Solve for x. This is the most, it doesn't get any more stereotypical math than this. Solve for x. Log base 2 of x equals 6. Later on in this chapter, later on in chapter 6, we're going to be solving logarithmic equations. You're already doing it. With this first video on 6.3, you're already solving a logarithmic equation. We're going to solve for this by saying, I don't like solving things with logs. Let's get rid of the logs. This is logarithmic form. Let's convert it to exponential form. So if this is true, then this is also true, just like example 1. And just like that, it's no longer a logarithmic equation. In fact, it becomes super simple. All right, 2 to the 6th power, type that into a calculator. X is equal to 64, I think. 2, 4, 8, 16, 32, 64, yep. There we go. That's this video. That's all there is to it. That's all there is to logarithms. They're just the inverse functions for exponentials. As long as you can switch between log form and exponential form, you're going to be good to go. Side note, sometimes I just like counting powers of 2 in my head. It's like see how high I can go in my head. Like 2, 4, 8, 16, 32, keep doubling, 64, 128, 256, 512, 1024, 2048, etc. Try it sometime if you want to be weird like me. Enjoy. Let me know if you have questions.